warahmatullahi wabarakatuh. My name is Adilia Okita Permatasari. I'm from Universitas Indonesia. Today I want to mention about my research. My research title is Resistivity of Hydrothermal Alteration using Dar-Zarouk parameter and concept of Anisotropy for study resistivity data. The outlines are introduction, concept of Dar-Zarouk parameter, result administration, conclusion, and my reference in my research. All the time, resistivity method is performed by using homogeneous approach and the concept of anisotropy. But in fact, the earth is not homogeneous and not isotropy. So the measurement of homogeneous approach and the concept of anisotropy are not interested as the earth real condition. This is the reason of my research takes holistic in homogeneous and anisotropy approach. The approach uses the parameter of Dar-Zarouk. The parameter of Dar-Zarouk is used to calculate resistivity of media and coefficient of anisotropy. Parameter of Dar-Zarouk proposed by on 1947. On November on 1988, using the concept of Dar-Zarouk parameter to estimate the sandstone aquifer transmissivity of Adilia in Southeast Nigeria. SZ on 2011 used the concept of Dar-Zarouk parameter to estimate the aquifer hydraulic properties in Indonesia. And the latest from Dar-Zarouk parameter uses that is used to predict the protective capacity of the aquifer in sandstone aquifer. From the research conducted so far, the Dar-Zarouk parameter is only used for 1D data processing to identification aquifer layer. So this is the reason I test the use of Dar-Zarouk parameter for 2D resistivity data by any cases to identification of hydrothermal alteration. So by this concept, it's expected obtained to cross-sectional model of subsurface collision, then homogeneous approach and the concept of anisotropy. Concept of Dar-Zarouk parameter. The important thing in this parameter relates to transverse resistance and longitudinal conductance. The measurement of the Dar-Zarouk parameter shown by this figure, where X is layer thickness, ρ is resistivity of each layer, C is total transfer resistance, and S is total longitudinal conductance. The mathematical equation for each parameter can see in my slide. This research aims to identification hydrothermal alteration focus on identification presence of silica mineral in this field. Silification zone identifies a high value resistivity of the measurement area. Before I want to talk about my result and discussion, I want to give information about my measurement line. I used two data for my research. There are data line M13 and data line M14. Line extended from southeast to northeast. And the color on this map presents silica from geological data. This research will compare two inversion model data. The first from raw data and the second from Dar-Zarouk parameter. From raw data, silification zone indicates at this stage 100 until 170 near the surface until depth about 100 meters. And for Dar-Zarouk model inversion, silification zone indicate at distance 10 until 200, and Dar-Zarouk parameter more give solidification zone more clearly than inversion raw data. And model and coefficient anisotropy model give information until this information green until red color is high conductivity zone. The result error 1.6% and 3.8%. And for M13 line, in inversion model raw data, in the insilification zone indicates at distance 100. Solidification zone is shown by red color, high resistivity or high resistivity. And model inversion Dar-Zarouk, solidification zone shown at 10 until 50 and 100 until 120 meters. In coefficient anisotropy cross-section model, 10 as precision. The conclusion for my research, one, comparison of the resulting cross-section model with homogeneous approach and isotropic cross-section model generated by the approach in homogeneous and isotropic solidification zone is more noticeable present when viewed from the model result with the cross-section approach in homogeneous and anisotropy. Dar-Zarouk parameter and the concept of anisotropy can be used to identify the presence of hydrothermal alteration in the field. And the last, using of Dar-Zarouk parameter and anisotropy sharpen the concept of hydrothermal alteration anomaly in the data so that the 2D resistivity can be more thoroughly seen and identified. And this is my reference. Finish for my presentation. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, we'll open with the question and answer session. Is there any question for Adilia? Okay, thank you very much. Next, please. Your name and your institution.
My name is Adilia Okita Permatasari. I'm from the department. So I want to ask, if I'm not mistaken, can you show this where there is a graph, the purification? This raw data and Dar-Zarouk is different method. So this two plots with projection show the same area in the tingkatan setting, but I see that as a very different result. I see Dar-Zarouk with that red zone, purification zone, and the raw data is that one. It's very different between those two results. So, why do you use Dar-Zarouk instead of raw data results?
Yes, because Dar-Zarouk parameter using concept in homogeneous and anisotropy. As you know, the Earth is not homogeneous and not isotropy. For raw data model inversion, from raw data model inversion, you took data in acquisition when you acquisition, but you assuming as English bahasa. You assume that subsurface is same. Okay. But the Earth not homogeneous. Because the Earth content of every layer has different conductivity and resistivity. It's different conductivity, conductance and resistance. So if you use raw data, it's not compatible from the Earth's real condition. Also, the raw data actually actually more used from Dar-Zarouk parameter.
So how do we know which one is good? Because when I see it, it's completely different results. So how do you know which one is good? And from the RMS error you shown, really the result gives you more error than the raw data.
For resistivity method, RMS error under 5%, still good, and it's not under 10% is acceptable and still